Hello. Hello everyone. This is your Dr. Nagaraju Pendam. Today we are discussing about the BSc Physics third year paper 6, that is subtitle is electronics. Actually previously I told all the odd semesters exam strategies I told. First semester and third semester and fifth semester physics and electronics important questions I told you. But now I told only two papers only. I told even semesters, second semester and fourth semester, physics and electronics. I told, but I did not tell the final year exam strategy. But students asked me, "Sir, you explain our syllabus. Why I did not take initially means there is a reason, because in a college by college and teacher by teacher, this paper will vary. Maybe if you are in your college, teacher is expert in electronics, and the lab facility also is there, then they will take the electronics paper. Otherwise they will take some another paper. These are the elective papers. According to your changing of syllabus, elective papers are there. Based on your college, this paper will be segregated like that. That's why I did not take the electronics and physics. But even though I confirmed you, because of your appealing, I am taking this one. This is the live session. After it will be recorded on our YouTube. So you have to listen and enjoy, and you qualify in this exam and get the good marks, maximum marks. I am giving this. Gunshot maximum marks you will get it in this examination. That is BSc Physics third year paper 6th, that is electronics, in your college. That's why I'm giving BSc Physics third year paper 6 electronics exam strategy by me, that is Dr. Nagaraju Pendam. According to your syllabus, 4 units are there. In the 4 units, BSc third year semester 6, paper 6, the title is electronics. In the first unit is band theory of PN junction. Band theory of PN junction. First year electronics people, first semester itself, this theory, second semester itself, they are reading this theory. But physics people, they will read in the final year syllabus. Band theory of PN junction. That syllabus once you have to see energy band in solids, that is the band theory, energy bands in solids. How we have to segregate the condensed band, valency band, forbidden energy gap in the solids, right? So you have to take it a conduction band. This is the conduction band. This one is a valency band. In between you have to take, that is the forbidden energy gap. Based on this, materials are, you have to classify into three types. One is a insulator, one more is a semiconductor, another one is the conductor is there. According to your syllabus, semiconductors are two types. One is a pure semiconductor, another one is impure semiconductor, otherwise intrinsic semiconductor or extrinsic semiconductors are there. Their extrinsic semiconductors are two types. One is N-type semiconductor, another one is a P-type semiconductor is there. Fermi level continuous equation. This is the first part of first unit, right? Once again, you have to see energy bands in solids is there. Based on the energy bands in solids, so conduction band, valency band, forbidden energy gap. Next one is based on these energy bands in a solids, materials are classified into three types. One is the insulator, semiconductors and metal. But according to your syllabus, PN junction formation is needed. So that's why you need the P-type semiconductor and N-type semiconductor, and their concentrations, continuity equation also there is there. Next, after making the PN junction diode, you have to make a diodes. Not only PN junction diode, PN junction diode application also is there. That is half wave rectifier, full wave rectifier, bridge rectifier. Next diode is a GNOR diode, and its application, GNOR diode application is GNOR diode acting as a voltage regulator. This is the your syllabus. Part 1 and part 2 is there. Part 1 is the introduction. Part 2 is a two diodes are there. One is PN junction diode, another one is the GNR diode. Only two diodes are there according to your curriculum. Once you have to see the questions. 5 short questions and 5 long questions I make it each and every unit. First unit 5 short questions, 5 short answer questions, and the second also 5 long answer questions I made it. Each and every unit I made 10 questions, right? Total 40 questions you have to read. You will get the 80 marks. Out of 80 also you will get it. First once you have to see. Describe the bond theory. What is the bond theory? You have to write. Just within 4-5 sentences you have to write. You will get the 4-5 marks. Write the classification of semiconductors. Now only I told two varieties of the semiconductors are there. One is pure, another one is impure. Otherwise intrinsic, otherwise another one is extrinsic semiconductor. Their extrinsic semiconductors are two types. One is p-type semiconductor, another one is the n-type semiconductor. You have to dope with p-type material, you will get the p-type semiconductor. You have to dope with a n-type material, you will get the n-type semiconducting matter. P-type doping means third group elements you have to dope. N-type doping means fifth group elements you have to do. Based on your knowledge, you have to write the classifications of a semiconductor. Derive the continuity equation. Del dot J is equal to continuity is equation minus dou rho by dou t. This is the continuity equation now. So you have to derive the continuity equation. Define the Fermi energy level. What is the Fermi energy level? So conduction energy level, valency band energy level. There is a Fermi energy level is there. That Fermi energy level you have to define and draw the circuit diagram. Circuit diagram means draw the energy band diagram. Explain the formation of a PN junction. How the PN junction should form, you have to explain. This is very, very important. These 5 questions you have to read as a short questions. Clear? Now I am coming into the long questions. Once you have to see. Explain the energy band in solids with valency band, conduction band, forbidden energy gap. By using a energy band theory in solids, you have to explain about the valency band, conduction band, forbidden energy gap. Clear? So that is the first one. Next, explain about the insulators and semiconductors. What are the insulator? What are the semiconductors? You have to explain. This is very, very important. Next, derive the carrier concentration of n-type semiconducting material, n-type semiconducting material carrier concentration, and p-type semiconducting material carrier concentration. You have to explain. Explain about the off wave rectifier. This question is very, very important. Pakka you will get in your examination. Explain about the off wave rectifier, full wave rectifier, and bridge rectifier. So 3 I make it in 1. But if you have to read these 3, you will get pakka 2 questions in your competitive exam. Off wave rectifier, what is the ripple factor, what is the efficiency, everything you have to read it, right? Next, explain the VI characteristics of a GNR diode. GNR diode VI characteristics you have to write. What is the application of GNR diode? GNR diode can act as a voltage regulator. How it will be work as a voltage regulator also you have to explain. In your laboratory also these are there. Characteristics of a VI characteristics of GNR diode or PN junction diode. These are the first unit questions. Once again you have to see these 2 questions are very, very important. Off wave rectifier, full wave rectifier, bridge rectifier, and voltage regulator. VI characteristics of a GNR diode and application of a GNR diode is very, very important. Clear? Now I am coming into the unit number 2. What is the unit number 2? In unit number 2, first unit is the PN junction diode is there. The second unit, the advance of the diode is a transistor, bipolar junction transistor. First part is a bipolar junction transistor. Second part, application of the transistor is feedback concept and oscillators are there. Application of the transistor. By using the transistor, you have to apply here. What is the feedback amplifier and what is the RC coupled amplifier and phase shift oscillator you have to learn here. Right. In BJT, In BJT means bipolar junction transistor. According to your syllabus, PNP transistor and NPN transistors are there. Current components, current component ante emitter current, base current, collector current, you have to explain in all the configurations. Common base, common emitter, common collector configurations. Transistor as a amplifier. How transistor works as a amplifier, that is also important. RC coupled amplifier, this is very very important. Pakka question will come as a long question. RC coupled amplifier and frequency response in qualitative analysis, not quantitative analysis. There is no need of derivation part. Only graph, you have to draw the graph, right? You have to draw the graph and you have to explain. Only qualitative explanation they need. Feedback concept and oscillators. Feedback, positive feedback, negative feedback is there. General theory of feedback. From this feedback, why we need the negative feedback? Concept of the oscillators. What is the oscillation? What is the negative feedback? What is the positive feedback? You have to learn. Oscillation, when it will be works, Burke-Hassan criteria, it is very very important. Phase shift oscillator, expression for the frequency of a phase shift oscillator. This is very very important. Only two parts are there according to your unit number 2. The first one is a bipolar junction transistor. The second one is the feedback concept and oscillator. That is the thing. How the questions will come in this, once you have to see. First, write the construction of PNP and NPN transistor. How the PNP and NPN transistor we have to make. That is very very important. Just very simple. Take a two ordinary PN junction diodes. N you have to attach, so you will get the, this is a P, this is N, PNP transistor, you have to get it. Otherwise you have to reversely you have to add it, you will get the NPN transistor you are getting. This theory you have to write as a short question purpose. Explain the current components of a transistor. Already I told current component, emitter current, base current, collector current, you have to explain. This is very very important. Write the general theory of the feedback. If you want to feedback, why we need the feedback, that is very very important. You have to write. Write the concept of oscillation. Oscillation concept you have to write. Write the condition for the Burke-Hassan criteria. Burke-Hassan criteria, this is very very important. Compulsory in your question paper, this question will be there. Burke-Hassan criteria. These are the 5 short questions. Already I told each and every unit 5 short questions I make it. You have to read these 5, that is enough for you. Now 5 long questions you have to write. Discuss the common emitter, common base, common collector configurations and their input and output characteristics. In your laboratory also you are doing this experiment, no? Common emitter configuration, input and output characteristics. From that also you have to write. Very very important. How the transistor works as a amplifier. How the transistor works as a amplifier. This is the application of the amplifier. You have to read. Explain about RC coupled amplifier. This is very very important. The third is very very important. RC coupled amplifier, and discuss the frequency response. Frequency response diagram. Explain about the phase shift oscillator. The fourth one also very very important. Explain about the phase shift oscillator and derive the frequency equation. Frequency of a phase shift oscillator equation. Discuss about the negative feedback oscillator. This one also they are asking combining with the Burke-Hassan criteria. Write the Burke-Hassan criteria and discuss about the negative feedback oscillator they will ask. But these 2 questions you have to read. One is RC coupled amplifier, another one is the phase shift oscillator. In unit number 2, only 2 questions are there. In the first unit, RC coupled amplifier. In the second unit, phase shift oscillator. In the first unit, these 3 configurations also you have to read. Only 3 long questions you have to read. You will get the 20 out of 20. So 20 marks weightage is there each and every unit. 20 out of 20 you will get it within 3 questions. First, third, fourth you have to read. 20 out of 20 you will get it. Right. Now I am coming into the third unit. So what is the syllabus of your third unit? Special devices. Special devices. What are the special devices? Now you learn now. BJT you learn. Next we are going to the some another advantage of the BJT. Advantage of the BJT, obviously FET, right? Here two varieties are there. One is optoelectronic devices are there. Optoelectronic devices are there, right? Two things are there. One is optoelectronic devices. Their optoelectronic devices, there one is the photodiode. The second one is the Shockley diode. The third one is the solar cell. The fourth one is a optocoupler. Four is there: photodiode, Shockley diode, solar cell, optocoupler. Right? These are the four optoelectronic devices. Next, next part is a field effect transistor and field effect transistor application amplifier. Next, third one is unijunction transistor. Unijunction transistor application is relaxation oscillator. The fifth one is silicon control rectifier, and silicon control rectifier application is switch. Silicon control rectifier acting as a switch. Only three concepts are there in the third unit. What are the three concepts? The first one is optoelectronic devices. Optoelectronic devices. Optoelectronic devices is the first one, right? The second one is FET, field effect transistor, and the application is act as a amplifier. Field effect transistor and amplifier, that application of the field effect transistor. The third one is UJT, unijunction transistor, and their application is a relaxation oscillator. Relaxation oscillator. At application is the relaxation oscillator. The fourth one is SCR, silicon control rectifier, and their application is a switch. So application is acting as a switch. Only 4 questions are there. If you have to read these 4 questions, you will get the 20 out of 20. Clear? You read these 4 questions, you will get the 20 out of 20. Once you have to see how you have to get the 20 out of the 20, you have to see. Draw the VI characteristics of photodiode. Photodiode VI characteristics, just you have to write. Draw the VI characteristics of solar cell. Solar cell VI characteristics you have to write. Discuss about the optocoupler. What is the optocoupler? What you learned according to your syllabus, that thing you have to write. How silicon control rectifier works as a switch, and how FET works as a amplifier. These are the 5 questions I make as a short questions. Right? Long questions you have to see. Write the construction and working of Shockley diode. Write the construction and working of a photodiode and solar cell. These are very important. Optoelectronic devices, 3 are there. These 3 you have to read. 4 are there. 4 you have to read. What are there? 4 is there. One is photodiode, one is Shockley diode, solar cell, optocoupler. These 4, any 2 questions you will get in competitive, in your exam, theory examination. Clear? Next, describe the construction and working of a FET. This is very, very important. Right? FET. Next, describe and construction the working of a UJT and mention their application. What is their application? Relaxation oscillator. The fifth one is describe the construction and working of SCR. Already that application I made it in short question. So that's why only long question I made. You read these 10 questions. Only 4 topics are there in unit number 3. 10 questions you have to read. 20 out of 20 you will get it in your competitive, in your exam, theory examination. Clear? This one you have to remember. Optoelectronic devices, 4 devices are there. That is a photodiode, Shockley diode, solar cells, and optocouplers. Next, FET, UJT, SCR. Only 4 topics are there in the third unit. Now I am coming into the last unit. What is the last unit? Digital electronics is a very simplest unit. Within 2 hours you have to read this unit. Digital electronics, binary number system, that is the base 2 number system is there, no? Conversion of the binary to decimal number system. Base 10 number system is a decimal number system. Next, binary addition and subtraction by using the ones complement and twos complement method. hexadecimal number system, that is a 16 base number system, conversion from the binary to hexadecimal and hexadecimal to binary, decimal to hexadecimal and vice versa. Any number they will give, so they want to ask the convert this to that, that to this, they will ask like this. First part is a number system only. First part, entire the first part is number system only. Already in first year you learn ACC paper is there, no? In there also you are learning the number system, correct? So ACC paper also you have to learn this number system. That number system you remember and you write, that is also fine. Now logic gates. Here three questions are there. One is ordinary gates. What are the ordinary gates? OR gate, AND gate, NAND gate, truth tables, and the realization of these gates using the discrete components. Discrete components, matlab, if you want to take according to your syllabus, whether resistors are there, you have to use the resistors. Otherwise, diodes are there, you have to use the diodes, whatever it may be. Next is the second one is a universal gates. NAND gate and NOR gates are universal gates. Why we call it as a universal gate? By using these gates, we have to construct all other components. Next, third one is exclusive OR gate also you have to add here. Next, De Morgan verification loss. So De Morgan loss. Only three questions are there. Truth table of logic gates and XOR gates, and next De Morgan loss, universal gates. Only three questions are there. So entire this unit within 2 hours you have to finish. You will get the 20 out of 20. Once you have to see, describe the number system, binary number system, octal number system, hexadecimal number system, decimal number system. You have to describe all the number systems, you have to describe. Next, convert this is a binary number. You converted this, the decimal number, you converted into a binary number. Like this, they will ask. Any number they will ask, I make one. Define the ones complement and twos complement with examples. You have to define what is the ones complement, what is the twos complement, you have to define. Define the De Morgan laws. What are the De Morgan? Two laws are there. Those two laws you have to explain. Explain about the exclusive OR gate. These are the 5 short questions. Very, very important, these questions. Maybe some problems also they will mix it here, right? Write about all possible conversions. All possible conversion means binary to decimal, decimal to binary, hexadecimal to binary, binary to hexadecimal, decimal to hexadecimal, hexadecimal to decimal, binary to hexadecimal, like that. Any conversion they will ask, you have to practice all the conversion problems. Describe the addition and subtraction using the ones complement and twos complements method. This question is very, very important, right? These 3 questions you have to read. Discuss about the OR gate, AND gate, NOT gate, truth tables, and their component method, single component method also you have to learn. Verify the De Morgan's theorem by using the logic gate. By using the logic gates, you have to verify the De Morgan's theorem. Next, discuss about the universal gates. What are the universal gates? NAND gate and NOR gate. NAND gate or NOR gate are the universal gates. You have to explain those things, right? These are the questions. Only 3 questions are there. 1, 2, 3. These number systems only. 4. Only 4 questions. Each and every unit also 4 questions are there. 1 day is enough for this to prepare this exam, right? 1 day is enough. You are also reading 1 day only, no? So that is the thing. Reference books for each and every unit. So many books are there according to your syllabus. But you have to take any third year electronics book, Telugu Academy book. You have to take. You have to read. Otherwise, you take the any paper. You have to take that one also. Nice, no problem. But that is the syllabus. So thank you for listening our which one our content. So please share our channel to your friends, subscribe our channel. All the best, okay, for your exam. Good luck for you.